to mathematics online lecture series, triple integrals. So today we will discuss another important question. Evaluate triple integral z square dx dy dz taken over the volume bounded by the surface x square plus y square equals to a square, x square plus y square equals to z, and z equals to 0. So now we will evaluate this triple integral over this volume. So in this problem, first we will find out the volume. What is the given volume? What is the region bounded by the given surfaces? Then we will find the limits. Then we will find the limits. Then we will find the integrals, integral value, evaluation of integrals. For this purpose, first observe the first surface. X square plus y square equals to a square. Actually, now this is x-axis, y-axis, z-axis. Now observe, x square plus y square equals to a square represents a circle in xy plane. In xy plane. But z value is not given. That's why x tend to z. X tend to z. This is nothing but a cylinder. This is nothing but a cylinder. First one is a cylinder. Now second one is x square plus y square equals to z. Suppose if you observe x, y, z. Suppose in this surface, if you put z equals to 0, it represents, when z equals to 0, it is a circle. Z equals to 1, x square plus y square equals to 1 is a circle. Z equals to 2, another circle. Z equals to 3, another circle. If you join all the curves for different values, different number of values of z, it represents a cylinder. Okay. Now I will join here. I will join here. I will join here. So, and also I will erase the unnecessary part. I will erase the unnecessary part. It represents a circle. Okay. And I will take it as some dotted lines. Okay. And z equals to 0. Z equals to 0 means xy plane. At this point, z equals to 0. So what is the volume combined with these three surfaces? Nothing but this one. This one. Common volume. Okay, fine. Then how to find the limits? Now triple integral of z square dx dy dz over the volume d equals to now x limits, y limits, z limits. Now along z axis z equals to 0 to this entire surface. What is the surface z equals to? 0 to x square plus y square. Okay. So along the axis, 3 dimension is over. Now coming to 2 dimension. Upper part is x square plus y square equals to z square when there is some value. Okay, then no problem. Or if you take any one. In 2-dimensional geometry, no projection on x-ray plane. Now this is a circle. Now along the axis, now lower curve is this one to upper curve. What is the lower curve? From this one lower curve is x square plus y square equals to a square. From this one, y equals to square root of a square minus x square with plus sign and negative sign. From negative sign to positive sign. Minus square root of a square minus x square. A square minus x square, here there is 0, to square root of a square minus x square. Okay. Now along x-axis, now this is the point here a0, 0. This is next to here minus a0, 0. Along x-axis, observe along x-axis, x limit minus a to plus a. Minus a to plus a, z square, dx, dy, dz. So first integrate with respect to z, then integrate with respect to what? Then integrate with respect to x. Very simple. Now integrating with respect to z, then integrating with respect to y, integrating with respect to x. Now integrating with respect to z, integral of z square equals to z cubed by 3. X is minus a to a, integral y is minus root over a square minus x square to root over a square minus x square, z cubed by 3. Now limit 0 to x square plus y square. So dy dx. So I will separate the terms. Okay. Now put z equals to x. X equals to minus, x equals to, integral x is minus a to a, y is minus root over a square minus x square to root over a square minus x square. Now 1 by 3 times x square plus y square whole cube dy dx. Now observe, if you integrate with respect to y, x is treated as constant, then integrate with respect to x. If you observe both the integrals, x square plus y square both are even functions. So this is an even function. Integral minus a to a f of x dx equals to, we have a formula, integral f of x dx from minus a to a is nothing but 2 times of integral 0 to a f of x dx. If f is even function. Here x square plus y square is an even function. If you replace y by minus y, you will get the same function. That's why this is 2 times of integral 0 to root over this one. And also this is also 2 times 2 into 2, 4 times of integral 0 to a, and integral y is 0 to root over this one and this one. Okay, I will solve in the next step. Okay, now this is 2 times 4 by 3 times of integral x is 0 to a, y is 0 to root over a square minus x square, x square plus y square whole square, whole cube, dy dx. Now integrating with respect to y. What is the methodology? Expand and integrate. 0 to a, y is 0 to root over a square minus x square. So a plus b whole square whole cube form, a plus b whole cube, a cube plus b cube plus 3a square b plus 3a b square. Using this formula, x square whole cube, x power 6, y cube, y square whole cube, y power 6 plus 3 into a square means x square whole square into y square. So 3x power 4 y square plus 3 into a is x square, b square is y square whole square. So 3x square y power 4 dy dx. Now integrating with respect to with respect to y. 4 by 3 times of integral x is 0 to 6, 0 to a, x power 6 integration to x power 6 into y with respect to y power 7 by 7 plus 3x power 4 y cube by 3, 3x y power 5 by 5, 0 to root over a square minus x square dx. Now put y equals to a square minus x square. 4 by 3 integral x is 0 to a, x power 6 into root over a square minus x square, root over a square minus x square whole power 7 by 7. Here 3 cancel. X power 4 root over a square minus x square whole cube, 3 by 5 into x into root over a square minus x square whole power 5 dx. Now, for integrating with respect to x, put x equals to a sin theta. Put x equals to a sin theta. Dx equals to a cos theta d theta. Now, and also, if you put x equals to 0, sin theta becomes 0, theta becomes 0. And when x equals to a and a cancel, sin theta is 1, then theta equals to pi. Now change the limits. 4 by 3 times of integral theta is 0 to pi by 2. X power 6, a power 6 into sin power 6 theta root over a square minus x square. I will write here. Root over a square minus x square is nothing but root over a square minus a square sin square theta is nothing but a into root over 1 minus sin square theta is nothing but a cos theta. So this term is a cos theta. Yes. This is also same. A power 7 cos power 7 theta by 7. Now this term is a power 4 sin power 4 theta into same a cube cos cube theta plus 3 by 5 a sin theta into, so root over this value is again a power 5 cos power 5 theta into dx is a cos theta d theta. Now simplification. 4 by 3 times of integral 0 to pi by 2. Here a power 6 into a into a power 7, a power 8. Sin power 6 cos theta into cos theta. Sin power 6 cos square theta. Plus here a power 7, here a power 6. Now observe a power 4, a power a cube, a power 7, a. Here a power 6. A power 5, a power 6. Okay, this is x square. 3x square. Okay, x square. X square means a square sin square theta. So here also a power 7 into a power 6. So a power 8 is the common term. 4 by 3 a power 8. Now first term is sin power 6 theta cos theta into cos theta, cos square theta plus sin power 7 into cos power 7 into cos theta, cos power 8 theta plus sin power 4 theta cos power 4 theta Here sin square theta 3 by 5 times of sin square theta cos power 5 into cos power 6 theta d theta. Now we will integrate with respect to theta. Okay, for the evaluation of this integral, we will use a very important formula. Integral 0 to pi by 2 sin power 2m minus 1 theta cos 2m minus 1 theta d theta equals to gamma m into gamma n by 2 times of gamma m plus n. Now we will use this formula for evaluation of this integral. Suppose for evaluation of this integral, put 2m minus 1 equal, now compare with these two, 2m minus 1 equals to 6, 2m minus 1. First I will evaluate this integral, then finally I will substitute here. Integral 0 to pi by 2 sin power 6 theta cos square theta d theta equals to, now comparing with this one, 2m minus 1 equals to 6, 2m equals to 7, so gamma 7 by 2. And also 2n minus 1 equals to 2, so gamma 3 by 2 by 2 times of gamma m plus n 10 by 2 gamma 5. So gamma 7 by 2 value is 5 by 2 into 3 by 2 into 1 by 2 root 5. Gamma 3 by 2 is 1 by 2 into root 5 by 2 times of 4 factorial. Actually, this is beta gamma function. We will discuss all these formulas in the next unit. So, after simplification, 5 3s are 15, root pi into root pi by 2 into 2 into 2, 16 by 2, 32 into 4 factorial. So, this is first value. In a similar way, I will write here first integral value 15 pi by 32 into 4 factorial. 4 factorial is 24. So, see if you simplify, 3, if you cancel 3, 5 pi by 32 into 8. 256. This is first value. In the similar way, second value. Okay, now we will evaluate second integral. This is first one. Integral 0 to pi by 2 cos power 8 theta d theta. Here, observe, 2m minus 1 equals to 0. There is no sign tan. 2m minus 1 is 0. M equals to 1 by 2. So, this is gamma 1 by 2 into using this triangle formula. Now, 2n minus 1 is 8. 2n minus 1 is 8. So, n equals to 9 by 2. Gamma 9 by 2 into 2 times of gamma 5. So, gamma of equals to root pi. Gamma 9 by 2 is 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2 into root 5 by 2 times of 4 factorial, like our previous problem. So, second value is 35 Here 4 factorial is nothing but 4 into 3, 624. This one is 8 times cancel. 35, 16 are 256. So this is second value. In a similar way, third integral. Integral 0 to pi by 2. Sin power 4 theta, cos power 4 theta d theta equals to, again same, 2m minus 1 equals to 4, m equals to pi by 2, gamma pi by 2. This is also gamma pi by 2 by 2 into 4 factorial, gamma phi is nothing but 3 by 2 into 1 by 2 into root pi whole square by 2 into 24. Here 3 cancel. So pi 4 power the 16 16s are 256. Third value is also pi by 256. In a similar way, fourth integral. Integral 0 to pi by 2 sin square theta cos power 6 theta d theta equals to gamma. 2m minus 1 is, again we are comparing with the same formula. 2m minus 1 is 2, m equals to 3 by 2. This is 2n minus 1 is 1, 7 by 2 by 2 into gamma phi is nothing but 1 by 2 root pi into 5 by 2 into 5 by 2 into 3 by 2 into 1 by 2 into root pi divided by 2 into 4 factorial. Same procedure, 3 and 3 cancel. So 5 by here 8 times 16 16s are 256. So almost 1, 2, 3, 4 integrals are evaluated here. So this is first integral, this is first integral, this is second integral, third integral, then this is fourth integral. Just immediately copy the 4 integral values. Finally, we will substitute in this integral. Okay, earlier integration is separately are integrated, we got the values. Now we will write all these things at a time. Four by 3 into 8 power 6 half. So this is already we discussed earlier. 2m minus 1 is 6, that is 7. Gamma 7 by 2 into gamma 3 by 2 by 2 times of gamma 5. Yes. Now second value, 1 by 7 times of, so 2m minus 1 is 0, m equals to 1 by 2, gamma 1 by 2 into 8 means gamma and 9 by 2 by 2 into gamma 5 plus third value, gamma 5 by 2, gamma 5 by 2 by 2 times of gamma 5 plus 3 by 5 times of gamma 3 by 2, gamma 7 by 2 by 2 times of gamma 5. Now 4 into 8 power 8 by 3 times of, so this value is already known, 5 pi by 2 56. Already you may write 5 by 2 into 3 by 2 into 1 by 2 into root gamma half is nothing but root pi. In a similar way you can write. Now second value, so second value is this one, 1 by 7 times of 35 pi by 256 plus third value 5 by 256. Now last value 3 by 5 times of 5 pi by 256. Now observe 5 times 4a power 8 by 3. I will arrange the bottom part. 256 is common term. 256. 5 is also common term. 5 times. Here 5 times 10 times. 1 11 times. 13 times. 5, 7 5s are 10, 11, 11 plus 3, 14. Now 4 pi by 3 into a power 6 into 14 by 256. Now simplification. 64 times, 7 times, 32 times, 7 by a power 8 by 32, 3s are 96 is the answer. Okay. Thank you, Media.